In this section, we're going to talk about arrays and look at a few examples of how to leverage the power of arrays in our programming. Basically, an array is a list of variables, and the reason that's important is that the list will keep track of the elements in the list, but it also keeps track of the order of these elements, and we can then call these elements by their index value, and there's just a lot of possibilities. Before we move forward with that, we do need to talk about how the items in the list, in the array, are indexed or numbered. Basically, the first element has an index of 0, not 1. So this can throw people off if they're not familiar with this. So if I'm trying to get the first element in the index in the array, the index will be 0, and so this diagram here is just an example of that. As far as declaring and creating an array, I wanted to go through all the different parts of that here. This might be a lot to take in. I just want to go through it bit by bit. Towards the bottom, you see an example of declaring and creating an array of integers. The different parts of it are the type. You have to specify what type, what kind of data it is. It could be an int, float. It could be an object, a string. All the data types that we've been looking at, and then you'll follow that up by these square brackets right here. And then you'll have the name of the array. In this case, what we're calling it array of ints. And then we're creating the array. We're using the equal sign, and we're using the new operator. New. You have to specify type again. And inside of the square brackets here, you should set the size of the array. In this case, it would be 42. So there'd be 42 elements in that array. And in this case, size must be an integer. You can't say 42.3 or 42.4. So that's important. As far as initializing an array, so we talked about an array being a list of elements. How do we fill it up? How do we fill this array of ints with integers? You could do it one by one by calling the index in this case. So 0 would be the first element, and filling it with 2, or in this case, and then the second one, which has an index of 1, you fill it with 7. The third one, index of 2, fill it with a 4. So you could do it in this way, a little bit tedious. You could do it all at once. So this is a really small array. This is only 3 elements, but this is an example of doing the same thing we just did in the other bit of code. So you could use these curly braces and fill the array that way. However, that's not, once we get really into a lot of different elements, it's not really efficient. So a better way to deal with it is perhaps using a loop. So here's an example of some code that would, if we're going through the phases again, let's declare and create an array. In this case, we'll do floats. So you have the type float, the square brackets, the name of the array of floats equals, we'll use the new operator here, new type again, float. And in this case, we're going to fill it with 50 elements. And then we'll initialize the array with random floats. And we can do this with a for loop. We could do it with a while loop as well. I'm going to do it with a for loop. So we'll start at 0, int I equals 0, while I is less than 50, and we'll say I plus plus, so it keeps advancing 1 at the end. And we're going through sequentially, and we're using, in the first time this runs, it's going to be array of floats index 0, which is the first one, and then we're filling it with a random number between 0 and 10, a random float. So this is perhaps a more efficient way to do something, especially if it's very tedious or there's a lot of repetition. In this example, we'll be taking some code that we've written before. There's a link to this code in the information on this video. It should link out to a GitHub. We're going to take a class that we wrote and use that, and then use an array to make many instances of that. So let's start just by grabbing that code. I have it already copied here, and what I'm going to do is make a new tab here. The class is called ball. It uses a sine wave to move up and down. So that code is all in here. Again, to just really quickly go over this, you write a class, you name the class, you have curly braces around everything. You'll have the data in here, the variables. You'll have a constructor that passes the temporary variables to the object variables. So you have all these temporary variables, and then you have any functions or methods here. In this case, it's just run, and this, like I said, is going to make a ball move up and down using a sine function to kind of drive it. So from there, let's build a sketch. Let's start with the setup first. We want to create a kind of horizontal sketch. I'm going to start with 800 by 400. And inside of we'll just set the drop first. This should be updating it, and we'll just have a white background for now. That's all we need. Oops. Okay, and we're gonna create an array. We'll declare that array at the top. So the array, the type is the object ball that we wrote. This class ball. We'll use 2 square brackets, and we'll name the array. It's several of these, so I'll just call it balls equals, and then we'll use new. We'll do the data type again, ball in this case, and we'll set how many how many of these we want. Well, let's start with 10. We still need to initialize the array, so that means give it values. And what I said earlier is using a for loop or any loop here will let us do it kind of quickly. Now we're going to use this notation dot length. This will automatically grab the length of this and bring it into here. I mean, we could say 10 for right now. The issue though is later on, if I change the size of the array, this will then not keep up with it. So I think it'll be better to write it as balls.length. Okay, so let's set it with a color. Right now, right now I might just give it like a red color, just and I'll go in and I'll make it more complex as we go along. The way that we fill it is we use the square notation, and we're going to use I here, so that again, an index or array starts with an index of 0. That's the first item, so it'll start with 0, then it'll go through, and then it'll add 1, and it'll be 1, 2, 3, 4 until it hits the end of the array. So this is where we initialize the array. So we call the ball here. Again, we have to pass it the same number of items and type that are listed in here in the constructor. So we're going to pass it the color C, that variable. Let's take the width. We want this to be spaced kind of evenly apart. So let's take the width of the sketch, and then we'll take balls.length again. So this is how we're dividing that into equal segments, so we're taking the width divided by 10 in this case. And then if we multiply it by I, this allows us to shift it over. It's almost like drawing a series of lines or a series of shapes, right? Where this allows us to increment things over. We'll start it at maybe, I guess we could start at height divided by 2, sure. Although I think I've said before that the Y value in the way that I wrote this, it actually gets overwritten later by with the sine and theta values. So that since I wrote the class with that, it's probably not needed, but I should keep it the way it is. The other thing I need is the size of the ball, I believe, the diameter, and then the theta. This also looks like it takes an increment. So I'm gonna want to make sure I grab that as well. Okay, so maybe I'll start with I as the theta. That's going to mean that things are offset, and with the increment, maybe I'll do 0.03. Okay, so that looks like it's good to go. And I just want to make sure that I close that out. Okay, so we've initialized it. Now, if we want it to run, we need to write another for loop down here. You could just copy and paste this. This is running it again. So inside of here, I'm gonna write balls I dot, and then the function that I wrote was run. So I'll write run here. So we'll use the dot syntax. Okay, let's see if that works. Great. So you can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of these, and they're moving. They're offset because the theta value I gave them was I. So this one is like 0, 1, 2, 3. So they start at different places. Yeah, that's a good place to start with. That would have been tedious to do it one by one. Let's go in and let's just start iterating. Let's say instead of 10, let's go to 100. And again, because I wrote dot length, I don't have to change it anywhere else. Like I don't have to go in here and change it from 10 to 100. It's gonna automatically update. And yeah, now I have a bunch of these sine wave balls. What we could do also, right now I set the color to red, but here you might also want to think about, can you use a variable or like especially I, since that's going to be changing over each instance, can you use it here to change the color? Maybe I'll do something like I times 2, or you could use the map function here. Maybe I'll do I times 200 minus I. So doing something like this, will give me kind of a gradient across. There you go. And I can add more again to really heighten this effect. So this is an example of, again, the modularity of code. We've written functions, we've written classes. The class kind of creates a template for us to use. And now if we use an array, which is a list of variables, we can create a bunch of these, right, and reference them. And because we're, think of this as a list, a sequential list, and we're going through one by one and calling them. So it's a really powerful tool. I want to do one more example, creating a class using object-oriented programming. And using arrays. I wanted to do something that'll generate this form. So the template that I created, the class, is an arc drawer, and you can see it draws all the way around, and once it hits the full rotation, it will kind of restart. And you can see there are many copies of this, so we're going to need to use an array to generate this. Let's start first by writing the class. I'm gonna make a new tab and call it arcDraw, and we'll go from here. ArcDraw. Oops. Put all of this inside of a curly brace. Let's give it some variables or some data. Color C. So I'm trying to think about how I might want to set this up. I want it to accept a color that I can throw into it. Maybe it's just a random color. I need a float X and a Y. The way that arc drawing works is you pick a center point and then you pick a diameter or a diameter or size, and then it uses angle values. So we're going to make a theta 1 and theta 2, and it sort of rotates along that angle. So theta 1, theta 2. We also need to have an increment for the angle. How fast does that move around? Let's see what else I might want to use. Maybe I have, if you look at that example, there was kind of a variety of thicknesses in stroke. So I might set that up here. And you know, I could feed them in, but I could also set it up to take a random number, let's say. It just might make the constructor and passing variables a little bit cleaner. So there's two ways to kind of set your data up. You can like declare them and then use a constructor to fill them in, you know, when you initialize it, or you could set it up like this. So now we're going to make the constructor. So this is passing the variables to each other. Again, we got to specify the type, and these are temporary variables, so I'm going to write temp in front of all of them. Float temp diameter, float temp theta 1. I want to make sure I don't mess up. I already messed up. Float temp theta 2. Float. I know, it's really annoying. And let's leave it at that. So I'm gonna open and close these curly braces, right? Just so you can kind of see. And then inside of, there's the open brace. Inside of here, I just gotta do my thing where I pass everything to. So it's a lot of work now, but it will make further variation and iteration a lot easier. Got to build the factory assembly line. And I hope I didn't mess up, but there's always the possibility. And I'll just fix it if I need to. Whew. Okay, so here I'm going to write my methods. I'm just going to write one method called run. We'll use parentheses and open and close curly braces. For the stroke weight, let's take S, and that gets defined up here. Okay. You know, probably, since I know everything's going to be in the center, I probably didn't need to write it with X and the Y, but it just makes it more flexible later. If I want to use this to draw things all over the place, it could be kind of fun. Okay, for the color of this, we're gonna use stroke C. That's the color, and we're gonna use the arc function here. So like I said, it's the center point, X and the Y, the size, how far out it goes. And you actually want to write it twice. It's kind of like an ellipse. It could be kind of ovular. So by doing this, it'll look like a circle. Theta 1 and theta 2, that's the angle range along which it rotates. And then what we want to do is take theta 2 and add a slight increment to it. And that's going to kind of increase the angle here. And like I said, there was one conditional statement that I'm going to use. It's like if theta 2 is greater than theta 1 plus 1 full rotation in radians is 2 pi. That's 360 degrees. So if that's the case, then let's take theta 2. This is like resetting it, and let's subtract. We can do subtract equal. So from theta 2, let's subtract 2 pi so that it starts back at the original angle. Okay, so I've created this arcdraw class. Now I want to create my sketch. Let's get the void setup and void draw out of the way first. You know, this hopefully is getting a little bit more clear and intuitive. I had a square-like situation. I'm going to do one other styling thing here. If you look at my stroke, the cap of it is something that we can change. There's a round edge you could use, or I'm going to use square. And let's see, what else do I need? In my draw, I had a background. I think it was black. And I don't want to fill on it. I just want to use the lines here. So I've got that set up. Now I want to create an array, declare and create the array. The type is the object, the class that I wrote, arcDraw. So if I was doing an array of ints, I would say int. In this case, I'm doing an array of objects, arcDraw. Let's go the square brackets, and I'll make an array called arcArray is equal to new arcDraw. We'll go to 50 right now, or maybe I'll do 10 right now just to keep it simple. Okay, now we want to initialize. So this right here is just declare and create. Whoops. Declare and create. Here we want to initialize the array. We're going to use a for loop again because it's going to be a lot quicker. It's repetitive to do it. We'll start with this. I is less than arcArray. And we'll say .length. We're going to use this again because we want to make sure if we change the length, it will stay updated. Okay, so that's the for loop to initialize it. And then we're going to go through here and use I as our index. And we're going to just set it up, arcDraw. Now, again, the type and the number has to match up. So we want to throw in a color. We can throw in a random color here. 255 random 255. Okay, so that's did I close that properly? Yep. So this closes that. That's the first thing. Then I need an X and a Y. I think I'll just put it in the center. So I'll do width divided by 2, height divided by 2. Though the next thing I had was the diameter. So let's just we could fill it with random diameter again. Random. Maybe it starts as small as 50 and it goes as large as 500 or 550. Okay. The next one was, I think, the stroke. No, sorry, what is it? Temp, theta 1, theta 2, and then we have the increment. So I'm going to try to remember that. So let's start with a range of values. We could do a random number. We'll go random pi. That's going to give us from 0 to pi. That's 0 to 180 degrees. And actually, let's do 90 degrees, right? That's going to be pi divided by 2. And then for theta 2, we want this to be bigger than theta 1 so that it's actually it's always moving in the same direction. If it was smaller, then it could be it might start on the other side of it. So we'll give it a range here, a minimum value of pi divided by 2, so it's never smaller. And maybe we'll go up to pi, so we'll go up to, 180 degrees is what I said. And for the increment, let's do a random pi divided by 64. So it's a pretty small value here. We have initialized the array. If we run it, this will tell us if we messed up. Stroke, I messed up some code. Temp theta 2, so what happened here? I probably wrote it wrong. Yep. This is just running it, but you don't see anything because we are not calling any methods in the draw, so we have to go through and call it. I'm going to just take the same for loop here because we're going through the same sequence. Again, an array is a list of variables which lets us go through it sequentially, and from here we're close. We're really close. All we're going to do is write arcArray, so we'll call the array. We'll use the square brackets and put I in here and then write run, which is our method. And from there we should have, yeah, this is our arc drawer, and you can see that, like, let's look at, for example, this blue one. Once it hits there, boom, it resets the angle. That was that conditional that we set up. So this is it with 10. This is it with 100. It's a lot. But that was so, once we set it up, it was so simple, so easy to move it around. And you could even do things like, you know, we set it up to go all in the center, but what if you set it up to be totally random, or random along the width? This could be interesting. It's just should be all over the place. Yeah, so again, the way that we write the class, you know, can affect how we use it later on. And again, you can make adjustments. Like if you want to add some more parameters, or, you know, accept more variables, you can just rewrite it and just make sure when you feed it, you give it the same type of variables and the same number. So that is another example of using object-oriented programming, making a class, and using arrays. So an assignment for you now is to do the same thing that we've been doing. Create your own class, sort of a template or an assembly line to create some sort of form, and then use an array to make many copies of it, many versions of it, and just create some sort of visualizer, something that, some interesting animation. Let's, maybe we'll just do one last one together. I'm gonna make something called, a class called a planet. I want to do sort of like a rotating circle. This is a way of using trigonometric functions, sine and cosine, to make circular movement. There are other ways to do rotation, but they involve other techniques. So I wanted to maybe show this first. So here's my class planet, and the variables that I'll need are, we'll start with float x, float y, float theta, that's a good one, and float increment. What other, so again, this is data. What other data do you think we would need? Maybe a color C, probably a float diameter, and maybe I'll just move some stuff around so it's more intuitive to me. I think in a lot of the examples I do it like in this order, so that might be more intuitive. From here, we're gonna make a constructor to allow the passing of variables. So we'll say planet, color temp C. These are all the temp variables again. Let's just do it's repetitive, I know, but hopefully the more you watch it, the more it makes sense. Temp diameter, temp theta, float temp increment. Close that off, and curly braces, right? So there's parentheses and the curly braces. Now we just pass it. C equals temp C, x equals temp x, y equals temp y, diameter equals temp diameter, theta equals temp theta, increment equals temp increment. There we go. Here we put our methods. So we'll just do a void run. Inside of here, what we want to do is, it's a planet, it's rotating around a center point. Let's see if we can think about this. The x and the y. So I did put an x and a y, but you know, now I just realized I probably don't need x and the y. I'm probably going to have it around the center. What we'll want to do is make an ellipse. Oh, actually, this will work. I'll take x and the y. Sorry about that. And what I'll do is I'm going to use a trigonometric function here. So theta times, and we want to multiply by something so that it isn't just going from -1 to 1. Let's say you know, maybe I should have put in a different number here. Actually, you know what? I need one more value here. Float distance. This is like the distance from the center. It's kind of like what I'm going to multiply it by, and I want to go in, and so this is maybe showing you how if you want to make an adjustment, you can totally do this. I'll go in here and say float temp distance, comma, and let me also go into here and say distance equals temp distance. Okay, so let me rewrite this. We're going to take distance, and then the way to create circular motion is to use sine on one axis and then use cosine on the other. The waves are such that they offset each other and they create a circular motion. So let's say, and you know, you don't need to totally understand that, but just know that when you use one here, you could have done cosine here and sine there, but you're using it on two different axes to get circular motion. And then the size of this is diameter. And you know, I should probably use the function circle instead of ellipse, but it's an old habit. And we'll do the fill. The color is C. Maybe there's no stroke. Maybe that's something you do somewhere else. But okay, so that's all set up. Let's go into our sketch, void setup. Okay, so we have the planet is the data type, is the object planet. We're going to set that up like that. And we want to create a new, let's call it planet array, is equal to new planet. You have to say it again what the data type is, planet, and let's just do 8 for right now. The size, we could make 800 by 800. And put a background here of, it's like space, I guess. Okay, so let's set this up. We have to fill in our array. We'll start with this for loop. We'll do I spelled planet array wrong. Planet array dot length. Again, that's so that if we change the length of this, it will stay updated. Let's add 1 to each. And from here, we're going to write planet array I equals new planet. The data type is planet. And we've got to, again, feed in the same number and type here. So I'm going to put in my random colors again, random 255. And you can control this, like let's say if you want it to be more red, you could change the values. Whoops. Commas in between each of these things. It'll be width divided by 2, height divided by 2 again. We want it to be in the center. What is x? So xy, diameter, distance. Okay. So maybe for the diameter, maybe it could be as small as 50 and as large as 200. The next one is distance. So let's use a random distance again. Here, maybe it's 100 to 400, because this is only an 800 pixel sketch. So if we go beyond 400, I think you'll rotate off of the screen. Whoops, I closed it too soon. Theta and theta increment. So here, you know, you could just put in a random number. Maybe it's random pi. That's between 0 and 180 degrees. An increment. So this is how fast it moves. So maybe sometimes it's bigger, sometimes it's faster, or you could even relate it to the distance. If you were able to figure out what the distance was, you could or make that a variable. You could use that to drive how big it is. Right now, I'll just put in a random number, so something pretty small. We could do pi divided by 64 again. That's pretty small. And close it all with parentheses and a semicolon. So again, I hope I did that all correctly. We'll find out. We'll go into here, and here we got to run the array, planet array I dot run, which is our function. Okay, here goes nothing. What happened here? There is no movement. Oh, I wrote this in such a way that I was not incrementing theta. Whoops. Theta plus equals increment. There we go. Let's run that again. There we go. So these are kind of our planets, and you can see they're orbiting around the center. Maybe these are too large, so I can go into here where the diameter I think was here 50. Maybe I'll do it small, 20 to 100. You should see that they're a lot smaller now. And yeah, again, if I wanted to do more, let's say I wanted to do 80, super simple. It's moving along. And the other thing that might be kind of interesting is instead of doing all random numbers, what if we took like I times 2, and so it's increasing in size, and maybe for the distance we can also say maybe it's I times 4. So I'm trying to think. Right now it goes up to 80. 80 times 4 is 320. I think that's okay. And then this is the random start. I mean, you might even say something like, what if it's I times pi divided by 64. This is like a small value. Yeah, I mean, there's so many fun things you could do just by setting it up differently. You kind of create different interactions here. So I hope that wasn't too repetitive or tedious, but going through the process again is helpful, and would love to see the kind of things that you generate using these techniques.